here are the values for your opener. And it's just filling in the blank. Okay, so this is just getting at some basic number sense. Okay, you do not need to be perfect at these. Okay, and for some of you, it might be kind of a guess and check game to figure out within your calculators what these values need to be. And what we're going to do is come up with a system for how can we come up with this value without actually just knowing the fact. Okay, so for the first one, -8 plus 8 is 0. 20 minus 20 is 0. -4 plus 4 is 0. Okay, the adding and subtracting should be fairly straightforward. Then when we write parentheses next to each other like this is multiplication. Okay, so now the math fact we're trying to think about is what times what gives us the value we're getting at. 4 times 3 is 12. Okay, -3 times -5 is 15. -2 times 6 is -12. The sign there is really important. Okay, if you can get to the number, great. But we need to be able to get to the positive or negative value as well. The division is where I think most of us would have a little bit harder time with. And again, this is all, anytime you see a fraction, it's just a division problem. Okay, so it's 200 divided by 10, that gets us to 20. 14 divided by -2 gets us to -7. And then -16 divided by 4 gets us to -4. Again, the sign matters. All right. Well, let's actually start to formalize this process and actually start solving here. So here in the bottom left are how we're going to go about solving each equation. We're going to get rid of some of these steps, but the first place we're going to start, just like when we're graphing, is we need to identify what type of equation are we looking at or what type of function. Okay, is it linear, absolute value, or quadratic? And knowing why each one is which. Okay, we won't deal with this today, but eventually we'll have to distribute. That'll be considered simplifying. Okay, all these 2 and 3, that'll all be something we do later. So today we'll be doing step 1. Getting one side of the equation to equal 0, I'm going to actually not have us do that. Okay, that changes a little bit in terms of it adds another step to our solving, and I don't want to deal with that. And then again, even with these, we're not going to get to that today either. So we will undo. Yeah, just get rid of all those. Those aren't going to happen today. So really the first one, and then we're going to undo the operation. So let's make a note of that. So identify type of function, and then we're going to undo the operation. So for a lot of you, if you're like, Mr. Younger and I need help, and you ask me to come over and help, I always start by having you read the problem to me. Because a lot of times when you read these things out loud, we're going to be able to figure out, okay, how are we solving this? And what do we need to undo? All right, so here's how we're going to go about solving. Just because we got a lot more room below these problems, let's just do 4, 5, and 6. Step 1 will always be identify the type of function. Now, when you get going, I'm not going to need you to write these down, but for today, I do want us writing these down. So basically, when we're identifying our types of functions, I pick up on the ones that kind of jump out to me. And number 6, that jumps out to me as being quadratic because of the exponent of 2. Number 5, that's jumping out at me as being absolute value because of the absolute value brackets. Then the first one, this is linear, and I kind of pick up on it being in linear as it's not absolute value and it's not quadratic, right? There's no absolute value brackets and there's no exponent of 2. So this one's linear. Now, what this is going to help us do is pick up on what the quick sketch of the graph looks like and then tell us how many solutions we should get. So this is what we did on Friday, where we looked at an equation and said, hey, -3x equals 45. Each side of that equation represents a line. Okay, so let's make just this quick sketch and they don't need to be perfect. And really all we're thinking about, where does the graph start? What is the slope? So does the graph open up or down? And then where are we looking for to intersect that? So let's start with just the intersection line. Remember 45, 14, and 125, those are all going to be just horizontal lines, right? It's like y equals 45, y equals 14, y equals 125. All those values are positive, so let's just draw a horizontal line above the x-axis here. And this is why it's a sketch. We're not drawing this to scale, but we can say that this represents y equals 45. This represents y equals 14. This represents y equals 125. And so then, for the left side, that's the actual function for what we're trying to graph. Okay, and where we just need to think about, really, what is the slope, okay, or the a value? Does our graph open up or down? So when I'm graphing negative 3x, that's just a line with a slope of negative 3. And I see that this intersects once, and so I'm expecting one solution. And if you're working ahead, I need you to come back and pay attention to what we're doing up here. You might be missing a really small thing that happens with these equations. Okay, absolute value. Okay, this is a negative 2. So this absolute value graph starts at the vertex and it opens down. And those don't intersect. So this tells me there's going to be no solution. And we'll talk about why that happens here in just a second. Then 5x squared equals 125. 5x squared, that's a quadratic or a U-shaped graph with vertex at the center and it opens up. And now I'm seeing that there are two solutions. Okay, so is this necessary for solving? No, it's not. Okay, but what it's telling us is how many solutions that we should get. And it kind of gives us an idea, should our solution be negative or one negative and one positive, or should they just be positive? Okay, so now let's talk about how do we actually solve each one of these, because they're a little bit different. And we're going to actually rewrite these problems and work them out. So I've got negative 3x equals 45. Our task is to get x by itself. And we get x by itself by undoing the operation. And as we get into more things going on to the x, we'll always work in the reverse order of operations. Okay, so if I see negative 3x, that means negative 3 times x. And so for us to undo multiplying by negative 3, we need to divide by negative 3. Now, as we start out, I'm going to draw a line down the equal sign. And the reason I do that is because if I add or divide or multiply or subtract to one side of that equal sign, I've got to do it to both sides. It's kind of like keeping our equation balanced is another thing you might hear. So when I divide by negative 3, that undoes us multiplying by negative 3, and it gets the x by itself. Okay, that gets to the solution, or that's what we're trying to isolate, is the x. And then the answer to the problem is 45 divided by negative 3. Some of us might need a calculator, and that tells us that x equals negative 15. So another way to kind of think about this is negative 3 times what number is 45? Well, we just found out what that number is, right? Kind of like the opener. Negative 3 times negative 15 gets us to 45. Okay, so the reason we started with that opener is it gives us another way of jumping into these solving problems. So we can think about it as negative 3 times what is 45, and that's negative 3 times negative 15. Okay, absolute value. Let's rewrite it. So negative 2 absolute value of x equals 14. And again, I'm going to give you two ways of how we can kind of jump into this. We can think about negative 2 times what needs to be 14, right? And that would be negative 7, right? If that absolute value of x is negative 7, I get negative 2 times negative 7 gets us to 14. Now, the solving part, just like what we did by getting x by itself, has me realizing that this is negative 2 times the absolute value of x, and I need to divide to undo the multiplying both sides by negative 2. And look at that. When I go 14 divided by negative 2, I get to the absolute value of negative 7. Now, what the heck? Our graph told us that there's no solution. We're getting that the absolute value of x equals negative 7. What's the problem with that? What's the problem with the absolute value of x equaling negative 7? Ruben, go ahead. Yes, right? There's no number that we can plug in that's going to give us a negative value, right? If I say that x equals 7, okay, and I take the absolute value of 7, well, that's just a positive 7, not a negative. Sorry, you can't see that. Okay, if x is 7 and I plug in that into that for x, I get the absolute value of 7 is positive 7, not negative 7. Well, what if x is negative 7 and I take the absolute value of it? Once again, the absolute value of negative 7 is positive 7. And thus, we'll never be able to plug in a number for x to get this to be negative. So we need to make a note. Okay, that absolute value of x can never equal a negative number. And that's why the graph is so helpful. Okay, because we can see that. It's really easy when students see the absolute value of x equals negative 7. I get it all the time that students will say, oh, the answer is 7 and negative 7. There's nothing in the algebra that kind of yells at us saying that we've done something wrong. The graph helps, and then we have to know this fact, that absolute values cannot equal a negative. All right. Louisa, did you have a question? I'm having a hard time thinking of what you're describing. You've got some wrong. Yeah, well, is that a problem that comes up in these notes? Yeah, just be patient. We'll get to that in a second. Because you have to get the absolute value by itself first before we can make that distinction of whether it's positive or negative here. Okay, last one. 5x squared equals 125. Let's rewrite it. And again, there's two ways that we can kind of jump in here. When I see 5x squared, that means 5 times x squared. So I can think about 5 times what number is 125. That's not an easy fact that I would know, right? It would be 25. So we are going to need this x squared to equal 25. Okay, 5 times whatever this is here, 25 is 125. And I can get there by knowing that 5 times x squared, I need to divide by 5. And then 125 divided by 5 is 25. So now, and this is why we have calculators, we need to think about how do we undo squaring something. If you look on your calculator, okay, the inverse operation of squaring is actually right above it. So if you look at the x squared, right above that is the square root button. That square root is how we undo squaring something. Okay, so when I square root the x squared, that's how I get x to be by itself. And then what we need to figure out is what is the square root of 25? And a lot of you are already really good at that. Square root of 25 is 5. Now, here's the problem. Our graph showed that we should get 2 solutions, but we only got 1. My calculator only told me that I got 5. Well, let's think about what this square root means. Have we talked about square roots in here? We did, right? We had a whole lesson on it. Okay, when we see the square root of 25, we're trying to answer what number times itself is 25. Okay, and the easy answer to that Okay, what number times itself is 25? Is 5. Right? 5 times 5 is 25. But is there another number times itself that gives us 25? A positive 25, Brian? Negative 5. Okay, positive 5 times positive 5 is 25, as is negative 5. Okay, so when we take square roots, we're going to get the positive and negative value of that. Okay, and again, that's because 5 times 5 is 25, and negative 5 times negative 5 is 25. Okay, so that's where that second solution comes from. So with the quadratics, we have plus or minus 5. Okay, so we're doing a little bit more with the solving by tying in the graphs. When we get this down, it gives you such a bigger view as to what we're doing when we're solving equations, and makes just any algebra you do from here on out, okay, you've got a lot of really good ideas tied into one concept of solving. Okay, so yes, I'm asking a little bit more to do these solving of equations, but it can be really helpful. All right, we're going to do next 3 again. And let's do just the bottom ones again so we have more space. And we're going to always start by identifying the type of function. So quadratic because of the exponent of 2. Absolute value because the absolute value brackets. And then linear because it doesn't have squareds or absolute value. So that's left over. Right above this, let's go ahead and make our graph. Starting with the right side, that's our horizontal line. So we've got a line at 3. We've got a line at -1. And we've got a line at 5. When you see x divided by 4, that's the same thing as 1/4 times x. And the reason that's helpful to know is it gives us an idea as to what the slope is. Okay, so x divided by 4 really just means we have a slope of 1/4. So our line's going to go like that, and we're going to get one solution. Hey, absolute value. When I see absolute value of x divided by 8, that's 1/8 absolute value of x. So that means our rise over run is up 1 and over 8. Gosh, dang it. We're going to get a no solution again. These do not intersect. And then quadratic, when you see x squared divided by 5, that really means 1/5 times x squared. So that is going to open up. Vertex at 0, 0. And once again, we're expecting 2 solutions. All right, so 2 ways of how we can think about solving this. One, I could use the math fact, like what I did with my opener, and think about what number divided by 4 equals 3. Well, that would be 12, right? If that number that's in my numerator is 12, well, 12 divided by 4 is 3. Well, how can we get there algebraically? Again, we have to undo the operation. If I read this and it says x divided by 4, I need to multiply by 4. Multiplying by 4 gets rid of the dividing by 4. And so now I get x equals 4 times 3, which is x equals 12. So I'm just multiplying both sides by 4. There's our one solution, so we are all done there. Number 11, absolute value of x divided by 8. Again, I can think about what does that need to equal? Okay, kind of like the opener. What number divided by 8 is -1? And that would be -8. So I need the absolute value of x to equal -8. Well, how can we get there algebraically? Absolute value of x divided by 8. I can undo the dividing by multiplying by 8. And then -1 times 8 is -8. And it's at this point, along with the graph that kind of gave us that hint, that absolute value cannot equal a negative. And thus there's no solution. All right, last one. Let's just simply think about, let's undo the operation and not think about what the numerator needs to equal. So I have x squared divided by 5. I can undo dividing by 5 by multiplying by 5. That gets rid of the dividing, giving me just x squared, and it equals 25. Well, now we need to undo the squaring. We undo the squaring by taking the square root. And just like we did the last time, it's the inverse operation of squaring on our calculator as well. Oh, look at that. We already did this. The same one. Square root of 25 is 5. My calculator will only tell me the positive value. And that's where I go back to the graph. I'm like, oh, I've got two solutions. So not only is it 5, but it's also -5. So it's plus or minus 5. Okay. For 13, 14, and 15, I'm going to ask that you all try these on your own. And let's do this. Let's put a line like right here. And just kind of organize this a little bit. Down here, I want you to name the function. And then draw a quick sketch of the graph to get an idea as to how many solutions you should get. Up here, we can do the solving. Try it all. Okay, if the graphs are confusing to you, you're going to be okay. Okay, the solving is kind of the main portion here, but let's see where we having trouble. So I've said this plenty of times over. All I need you to do is try right now. So from the graphs and identifying the function name, 13 is linear. We're trying to figure out where the linear graph intersects with the line of -35. So we're below the x-axis. It's a positive slope line. I'm getting one solution. Absolute value. We're trying to figure out where it intersects at -6, so below the x-axis. The a value is -1/4, so it opens down. So we are going to get two solutions here with the absolute value. Okay, that's the first one that we're going to see with absolute value that has more than one solution, or just a solution in general. Then the quadratic. 54 is above the x-axis. Our quadratic opens up, and so I'm getting two solutions. Any questions about me coming up with the graphs or what it's telling me? Hey, again, it's not essential to solving, but really helps us pick up on when there's no solution or multiple solutions. Okay, so now the solving. I see 5 times x equals -35. I can undo the multiplying by 5 by dividing by 5. -35 divided by 5 is -7. Then I have the absolute value of x divided by -4. I need to multiply both sides by -4. And I get the absolute value of x equals +24. I'm not done with the problem yet. This is not my answer. I'm not solving for the absolute value of x. Rather, I'm solving for just x. So we need to think about what two numbers can I take the absolute value of that'll give me 24. Brian, what are they? Just like quadratic, it's plus or minus that value we get. Okay, the absolute value of +24 is still +24. The absolute value of -24 is 24. Okay, when we take the absolute value of a number, we just always make it positive. Six x squared equals 54. That's 6 times x squared. I need to divide both sides by 6. 54 divided by 6 is 9. So I have x squared equals 9. Then I need to undo the squaring by taking the square root, where the square root of 9 is plus or minus 3. Okay, questions here. All right, let's do 3 more together, and then we'll skip the last 3 because we're going to run out of time. But now we're going to deal with some fractions here, and we're going to deal with it in 2 parts. All right, so just like before, let's name the function and do the graph. This first one is linear. Again, it's because I don't see an exponent of 2. I don't see absolute value brackets. 17 is absolute value. I'm okay with us abbreviating these. And then 2x squared is quadratic. Now let's quickly draw the sketch just so we can figure out what kind of solutions we should get here. We'll do that at the bottom. Right side is positive 10. For the absolute value, the right side is negative 6. And the right side is positive 10. And then now we just really need to decide, is our A value or the slope positive or negative? Well, with the line, it doesn't really matter. 5/4. So it's positive slope, and I'm getting one solution here. This absolute value, that's like negative 2/3 times the absolute value of x. That is negative. So it opens down. And I'm saying that we should get 2 solutions with this again. And then the quadratic, that is positive, so it opens up. And thus, we're going to get 2 solutions. Okay. So here's what we're going to do. We're going to get rid of the fraction by treating it like 2 separate problems. Okay, when I see 5x divided by 4, the 2 things that are going on is I'm dividing by 4 and multiplying by 5. So we're going to undo the fraction in 2 steps. We'll undo the division part first, and then we'll undo the multiplication part second. So for this first, number 16, I see 5x divided by 4. I'm going to multiply both sides by 4. That's how I get rid of the division. So the 4's go away. And I get 5x. And it equals 10 times 4, which is 40. Now this looks just like a problem that we started with. Right? This is 5 times x equals 40. I can think about 5 times what is 40? That would be 8. Or I can divide by 5. And 40 divided by 5 gets me to 8. 5 times x is 5x. There's our one solution. All right, almost the exact same idea for number 17. Let's get rid of the division first. So this is negative 2, absolute value of x divided by 3. I'm going to multiply by 3 to get rid of the division. So I have negative 2, absolute value of x equals negative 18. Now I have negative 2 times the absolute value of x, so I need to divide by negative 2. And I get that the absolute value of x equals 9. I should have 2 solutions here. So I'm thinking about what numbers can I take the absolute value of to give me 9, plus or minus 9. And last one, quadratic. Let's get rid of the dividing by 5 by multiplying by 5. So 2x squared equals 50. Then divide by 2. x squared equals 25. And then square root. We've square rooted 25 a couple times today, so I don't need my calculator. I remember that it's plus or minus 5. All right.